short video, we recovered the formula for the characteristic polynomial that you probably learned in your previous linear algebra class in terms of the determinant. So this is Theorem 10.25, and it states that the characteristic polynomial of t, some operator on v, is given by the determinant of zi minus t. Now, in case you were expecting this to be the determinant of t minus zi, the issue is just that silly -1 to the power of n, which sort of makes a mess about things. So you'll find different conventions in different textbooks. So in some places they'll talk about the determinant of t minus zi instead of the other way around. And they'll also talk about finding eigenvalues by doing lambda I minus t instead of t minus lambda I. There's advantages and disadvantages to both. It doesn't really matter as long as you're consistent. So this is one case, however, where it becomes a lot easier because of that annoying -1 to the end, just to deal with zi minus t. All right, so first off, we observe that it suffices to prove the case when v is complex, and that's because the same argument can be repeated for the complexification. Whoops, that's not how you spell argument. Argument. Okay, so first off, the general principle is that if you have if you perturb, say we take an operator t and we perturb it by subtracting something from just the diagonal of t, then this thing is going to have eigenvalues of lambda minus z. And so to see this, we'll work with the negation of this expression. Notice that z minus lambda is an eigenvalue of zi minus t if and only if, so we need zi minus t, our operator, minus, and then the diagonal perturbation is not invertible. Whoops, is not invertible. Oh no, I ran out of room. Okay. And so that is not invertible if and only if lambda is an eigenvalue of t, and the reason for that is because we can rewrite things in terms of this identity, namely that minus t minus lambda I is equal to zi minus t minus z minus lambda I. So you see what happens on the right hand side. This zi and this zi cancel with each other, and then you just have the thing over on the left hand. But in the meantime, you can see that lambda is an eigenvalue if and only if this one is not invertible, which means this one is not invertible, which means that z minus lambda is an eigenvalue of this guy. Okay. So then The result follows by the definition of the characteristic polynomial as the product of all the eigenvalues.